Did you feel that? No. Dear Tim and Moby, why do earthquakes happen? From Daniel. Hi Daniel. Here on the surface of the Earth, things are usually pretty calm and stable, so you might think our planet is just a big dead rock. But along with volcanoes, earthquakes are a powerful reminder that we're living on top of a fiery ball, protected only by a thin shell. This rigid outer layer is called the lithosphere, which means ball of rock. But the ball isn't solid, it's a hollow, cracked shell. Each piece of this planetary jigsaw puzzle is called a tectonic plate. Well, beneath the plates is a layer called the mantle. And farther in, you have the core, which is about as hot as the surface of the sun. That's easily enough to melt the mantle, but the weight of the lithosphere keeps it sort of half solid, like clay. Driven by the core's heat, the mantle slowly churns in movements called convection currents. Over millions of years, hot material rises away from the core, cools off, and sinks again. Since the plates are floating above, they get dragged along for the ride. No, you can't usually feel the movement. It's really slow, generally about a couple of inches a year. But it's an unstoppable motion, and in some places it breaks the Earth's crust into long faults. These cracks are the most common near plate boundaries. In some places, the slabs of rock on each side of a fault move smoothly, but in others, the slabs get stuck while the mantle below keeps moving. So a whole lot of pressure can build up over many years. Eventually, the crust shifts, releasing an enormous amount of energy. Yep, that release is called an earthquake. The energy moves outward from the hypocenter, the spot on the fault where the pressure first releases. The spot on the Earth's surface directly above the hypocenter is called the epicenter. Now, believe it or not, hundreds of thousands of tiny earthquakes happen every year. They're just so small that people can't really feel them. But sometimes a tremendous amount of energy is released. The energy travels through the ground in the form of seismic waves. Some of these waves push straight outward, creating an explosive thud. Since these waves are the fastest, that's the first thing you feel during an earthquake. After that, you'll feel a rocking motion as slower waves move material up and down. These kinds of waves create ripples on the surface, like a rock tossed into a pond. That's why the most intense shaking comes at the end of an earthquake. The surface waves rock buildings and other structures back and forth on their foundations. If the building materials aren't strong enough, they can collapse or fall over. And even after those waves pass, places that have been shaken up still have to worry about aftershocks. Those are unpredictable earthquakes that occur shortly after big seismic events. They can be pretty strong and wreck buildings that have been damaged by the first quake. Quakes are measured and recorded using a machine called a seismograph. A seismogram shows us how big the waves were and how long they lasted. And the intensity of an earthquake is measured on the moment magnitude scale. It runs from 1 to 10. Each number represents an earthquake 10 times stronger than the one below it. So an earthquake that measures 4.0 is 10 times more powerful than a 3.0 earthquake. Major earthquakes tend to measure 7.0 or higher. In 1906, an 8.0 earthquake basically wiped out the city of San Francisco. That's true. California is on the Ring of Fire, a region of frequent seismic activity. The plates in this area are constantly grinding against one another, fueling volcanoes and earthquakes. Many of these happen underwater, which can create an incredibly destructive wave called a tsunami. During a tsunami, waves up to 100 feet high can destroy shorelines for thousands of miles. And that's what happened in 2004, when a 9.2 earthquake rocked the Indian Ocean. Well, there's rarely any warning before an earthquake hits. But if you live in an area that's prone to earthquakes, like the west coast of the United States, you should probably take a few precautions. Create a ready kit of essential supplies in case you need to evacuate quickly. And plan how you and the rest of your family will contact each other. If there's a strong earthquake, get to a safe place inside your house, like against an interior wall or under a sturdy table or desk. Be sure to hold on. Don't tell me you didn't feel that. I get why we're under the table, but why are you squeezing me?